Okay, so here I'm going to do 3 examples of finding horizontal asymptotes. Find the horizontal asymptote of this function, and this function. There's 3 basic situations for horizontal asymptotes. The degree in the numerator and denominator, the degree is if the exponent value is the same in the numerator and denominator. If the degree in the numerator and denominator is the same, then the horizontal asymptote is y equals the ratio of these leading coefficients. 1 over 1 is 1. That's the answer. Let's say, let me just change this a little bit. Let's say instead, let me just change this to 5x minus 6. Well, still the degree in the top and bottom are the same. It's a degree 1 over degree 1, x to the 1. What's the ratio? Well, the coefficient of x in the top is 1. The coefficient of x in the bottom is 5. So therefore, the horizontal asymptote is y equals 1 over 5. It doesn't matter. Even if this was an x to the 4th over 5x to the 4th, the degree is still the same in the top and bottom. The degree is 4. So still, the horizontal asymptote for this is 1 over 5. You're going to get the same answer. All right? So that's the idea if the degree is the same in the numerator and denominator. Well, now we have 2 other situations. The degree in the numerator is larger than the degree in the denominator. The degree in the numerator is 2. The degree in the denominator is 1. Whenever the degree in the numerator is larger than the degree in the denominator, you either have no horizontal, there is no horizontal asymptote. So let me just say no HA. There's no horizontal asymptote. So that always is the case when the degree in the numerator is larger than the denominator. The only other thing that can happen is when the degree in the denominator is larger than the numerator. If that's the case, then the horizontal asymptote is going to be y equals 0. The reason why is because here, keep in mind your horizontal asymptote happens when x goes to infinity or negative infinity. If my graph levels off to one line as x gets really big, we have a horizontal asymptote. Well, as x goes to infinity, the value of this fraction actually gets closer and closer to 1/5. As x goes to infinity here, the value of this function just goes to infinity. That's why there's no horizontal asymptote. Here, when x goes to infinity, the denominator is a larger exponent than the numerator. So when x goes to infinity, the denominator gets bigger way faster than the numerator, and the overall value of that fraction goes to 0. So those are the 3 main situations to identify horizontal asymptotes.